Hello everyone. So this is the last topic of our class, topic number 11, which has to do with flow rate and capacity analysis. Now I've taken two topics within this topic out. They're no longer there, the theoretical capacity utilization and the capacity multiplier. Now, so basically the topics that we're going to be covering now today is basically the theoretical capacity, the resource pool, and the normal capacity utilization, not the theoretical capacity utilization. So let's start. So if you guys remember when we covered, we touched a little bit on capacity, we said what's very important for us is the effective capacity. And this is what we're going to be studying. The overall capacity is never realized, so we're going to be talking about effective capacity. Now, it's very important, the very important thing that we need to talk about here is resource units and the difference between resource units and resource pools. So here we have an example of a bakery. So if we have three flexible bakers that can perform any baking activity, which is basically they could do mixing, kneading, and forming of the dough. If they could do all three, then we think of them as one resource pool. So one resource pool. Now, if we specialize the bakers, so one baker only does the mixing and one baker only does the kneading and forming the dough, then we end up with three resource pools. Okay, so you could think of this also in supermarkets. If you have the person handling the cash, if that person does cash handling and packing the groceries, then that would be one resource pool. Now, if you have two separate individuals, one handling the cash and one packing the groceries, then we would have two resource pools. Now, in the case of the bakery, even though we have one resource pool, but we still have three resource units within that resource. So we still have three resource units. And here we still have three resource units. So the number of resource units is not affected by whether you have specialization or no specialization. We still have the same number of resource units. So if we have the three bakers all experience in doing all different three activities, there's still three resource units, but they're in one resource pool. While if each one of them is specialized, then we have three different resource pools, but we still have three resource units. So the resource unit doesn't change, the number of resource units don't change, but the number of pools will change. So the resource units are not going to change the number of resource units whether you change the number of resource pools or not. Now, it's very important for us to understand that combining several resources pools into a single resource pool is a very powerful tool. It's called resource pooling, but it's a very powerful tool that can affect process flow measures in a positive way or improve process flow measures. Now we've seen this. We call this also cross training. So we've seen this in COM 225 at least as cross-training. And cross-training meaning is basically you train your employees on more than one task. So the employee could do a multiple task, and this is quite efficient and effective, especially in times when demand is high. One example of that is at a supermarket. When things are really busy and there's long lineup of customers trying to check out, what happens in a supermarket is they usually have people in the back come and work the cash because they're trained. And once this happens, so you have more stations for customers to check out their items, and that would reduce the congestion or reduce the lineups. So it is a very powerful tool, what we call resource pooling and trying to combine a lot of resources in one pool. Now let's look at the equation for effective capacity. And now we get to the first thing we need to look at is what's a unit load. Unit load is basically how long it takes to process one unit by a resource unit. A resource unit, you could think of it as an employee, as a laborer, as a specialist. Sometimes it could be a machine. So basically, unit load is how long does it take to process one unit? In the service industry, how long does it take to service one customer? So now effective capacity of different resource pools is always dictated by the slowest resource pool, which is the bottleneck. So the bottleneck will always dictate the effective capacity of the whole system. So also if we have processes that are in series, and let's say this one is the bottleneck process, so this process takes longer than all the other processes, then the whole system is going to be dictated by this process. So the capacity, the effective capacity of this process is basically the effective capacity of the system. So we have to remember this. Now let's get to the equation, and the equation is this, which is the effective capacity of a resource pool. So we're looking at a resource pool, and which is basically CI, which is the number of units within that resource pool, over TI. And TI here is the unit load. Now please do not confuse the unit load. Let's use red here. The unit load, don't confuse it with what we've seen from the previous lecture on flow time. So flow time is different than the unit load. Unit load. So they're totally different things. So let's see this example. So we have, this is an residential insurance claim question. So here the flow unit are insurance claims, and the resource unit are basically these agents that are processing the claims. 2 agents are available for the process, so the resource pool has 2. And now we have 2 equations that we might be using: the effective capacity for one resource unit, and then the effective capacity of the resource pool. Now the first thing we want to do is calculate TI, which is the unit load. It's given to us as 12 minutes per claim, so 12 minutes per claim. And the question asks us for the effective capacity of a resource unit. So be careful here, they're asking us for a resource unit. It's not for the whole resource pool. So for each agent, so it's the effective capacity of each agent, which is going to be 1, so it's going to be this equation right here. So 1 over 12, which is going to give us 5 claims per hour. Now the effective capacity of the resource pool is just because we know there's 2 agents, so we know that there's 2 agents here. So we just take these 2 agents and we multiply them by what we got in terms of the effective capacity of the resource unit. So we know how much the effective capacity of one resource unit, which happens to be 5 claims per hour, we multiply by 2 and we get 10. Now we could have used the equation also. We could have said effective capacity is equal to CI over TI, which happens to be CI is 2 because we have 2 agents in that resource pool, and TI is 12, so that gives us 1 over 6, but that's claims per minute, and when we convert it in terms of hour, we should get 10 per hour. So 10 is the same thing as 10 claims per hour. Okay. So basically, this is a good question because it's asking us about the effective capacity of one resource unit and the effective capacity of the whole resource pool. So notice they are 2 different things because one is for the whole resource pool, which includes all the different resource units within that pool, and the other one is simply just the effective capacity of that one resource unit. So let's move on to another example. Here we have insurance physician claims. And we have a process that starts at the mailroom and goes to data entry, claim processors, and claims supervisor. So we start by, so mailroom is first, then the data entry, then processor, and supervisor. Now, very interesting. If it turns out, so the actual capacity of the process will depend on the bottleneck. So whichever process is the bottleneck is going to dictate the effective capacity for the whole process, because the question is asking about the effective capacity of the whole process. So we're going to calculate each effective capacity for each resource pool separately. So we know that, so these are the unit loads. So they're giving us the unit loads, which is minutes per claim, and this is exactly what it should be. It should be time per job, per claim, per product. This is the number of units in the resource pool. These are number of resource units. So resource units. So a very good method is to always to start calculating the effective capacity of the resource unit, one resource unit, which is very simple. Where in this case we have it's 1 over Ti, and Ti in this example is going to be 1. So remember, the effective capacity is equal to 1 over Ti for one resource unit. And then for the pool, we just multiply that by Ci, just like we did in the previous example. So we get 1. So now we move on to the next resource pool, which is the data entry clerk. The TI is 5. So the effective capacity for the resource unit is 1 over 5.2. And then we multiply it by 0.8 to get the effective capacity of the whole resource pool. Now we do the same thing for the claim processor and supervisor, get 1.5, 2.0. Now the effective capacity of the overall process is basically dictated by the bottleneck, which is this process. The mailroom is the bottleneck. It has the smallest effective capacity. It could process less than any of the other departments. So this will dictate our effective capacity. So the effective capacity is going to be 1 claim per hour, which is basically the bottleneck, because this is the bottleneck. Or you could think of it as the job or the resource pool with the lowest effective capacity.